Now that welcome back, guys. We are doing this question here, and this. Okay, guys. To get the subarray sum between two indexes, what we can do, we can use the prefix sum, right? So here, 4 here, 9, 9, then 9 minus 2 is 7, minus 3, 4, plus 1 is 5. This is prefix sum like 0, 1, 2, 3, 4, 5. Like if I want uh, the I comma subarray sum of uh, what we can do is we can use like a prefix of j minus prefix of I minus 1. Like let's say between this and this we want like 0, 1, 2, 3. So prefix of 3 minus prefix of 0, right? Which will be 7 minus 4, which is uh, 3, right? So you see 5 minus 2 is 3. So here how we can get the subarray sum between two indices, right? Now the question here is that if return the number of non-empty subarray that have a sum divisible by k, right? So if like this is divisible by k, right? It means pj minus p of I minus 1 modulo k is equal to 0, right? Where what we can do, we can do this pj mod k is equal to p of I minus 1 uh, mod k means if like we subtract something, right? Like we subtract 4, 8 minus 4, right? And then we modulo it. If modulo with something like let's say 2, right? It will be 4 modulo 2, which is 0. If it is, we are doing like this. If our modulo subtract division is 0, that means here subtraction, the value here is a multiple of k, multiple of k, right? If it was not like any of these values were not multiple of k, right? Uh, then it would have, let's say it was 3, or it was 5, or it was 3, right? Then 5 modulo 2 would have been 1, right? So in that case, uh, And one more rule we can find out is if two numbers if two numbers have same divided by k, right? Then their difference is a perfect uh, multiple of k. So let's say we have 9 and we have 3, right? So 9 more 2 equal to 1 and 3 more 2 equal to 1. So these 3 and 9 is both modulo, both remainder are 1, right? Now if I do 9 minus 3 modulo 2, which is 6 modulo 2, which is 2. So this is perfect multiple of 2, right? So we can do this. So when I do keep running this prefix, total prefix of an array, right? Alright, so when I keep running a total prefix sum of an array, right? So we are just generating a sequence of numbers like this here. Right? At index 2, our total sum is something 9, right? If I divide it uh, by 5, it is modulo 4 here, right? At index 5, so total sum is 5. If I divide it by 5, the remainder is 0. So and here again, if I do this index, both remainder are same, right? 2 and 2. So because remainders match here, so math will guarantee that uh, between that the numbers we added, right, between index 1 and 2, right, between must add up exactly to like like this is 9, this is 9, so must add up exactly to 5, right? And 5 is divisible by 5. So that is why uh, we only need, because this 5 minus 0 is 5, right? And divisible by 5. So that is why we only need to track the remainders. Every time we see a remainder you have seen before, you just found a valid subarray in that case. Because it's a multiple of 5, right? Because if they have the same remainders, right? To when I divide by 5, right? Then the sum of those elements, because I have to subtract to get the subarray sum. I have to subtract it from here, right? Then let's say right. So and one more thing, we cannot use a sliding window here because this array contains negative numbers, right? But our sliding window property works on the monotonic property, right? Which means that uh, adding a number into the subarray will always make the sum bigger. It will not reduce it, right? So remove number always makes the sum smaller. So that was the monotonic property, but this is negative contains negative number. So if we have negative, right, expanding our window might make the sum smaller and it sum bigger also. It can make the sum bigger. Right? So how this problem traps our thinking? Similar problems like interviewers loves this problem because it looks identical to other famous problems, right? But it requires a completely different hash map key here. Here is how to keep them separated in our head. Okay. First trap is confusing with a subarray sum equals to k, right? There is a LeetCode 560 problem, like 5 subarray that equals exactly k, right? So math will be like same as prefix sum, right? Then we store the exact prefix sum. You search for map for current sum minus k. Current sum minus k here. And second trap we can get into is our zero. The base case trap, like mistakes we have, like candidate initialize an empty hash map of frequency array and just start looping, right? So if the first three numbers in there is sum to exactly 10 and k is equal to 5, the remainder is 0, right? So you look in our map as past 0 and find nothing and count 0 valid subarrays. But the subarray sum index 0 to 2 is perfectly valid. So how we can figure that by pumping the recording that we have seen a remainder of 0 exactly one time before the array even started. Remainder frequency 0 is equal to 1. This will represent the empty prefix index 0. Okay, so that is how we can do this, and let's try to code this. Okay, all right, let's try to solve this now. first, what I will get a frequency array to track how many times we have seen each remainder. Remainder will be between 0 to k minus 1, right? So vector and uh, remainder frequency, right? Which k comma 0 in that case for now, right? And what will be our base case? Like we start at remainder 0, right? So before we have processed any number, if a prefix sum itself is perfectly divisible by k, it forms a valid subarray, right? From the very beginning. So our remainder, the frequency of 0 equal to 1, right? Then we will have our prefix sum here equal to 0 and valid sub arrays, right, equal to 0. Now in this, what we can do is we go in our first we have to for integer equal to 0, right? I less than nums dot size, right? So you see here size I plus plus. Now we will count like calculate the prefix sum that is equal to nums of I, right? Now int current remainder, right, equal to prefix sum minus sum plus k modulo k. No, not like this. We have to equal to prefix sum modulo k plus k modulo k like this. Right. Then we will have this. If our current we have like we have seen this, right? So our valid subvariable count will increase, right? Sub array plus equal to this remainder frequency of current remainder, right? And then we increase the remainder frequency of current remainder. This means after it we will return the valid sub arrays. Right, let's check if it is correctly finding that or not. It's accepted. Let's try to run this. Right. Okay, it's beating most of the implementations and all the cases passed. So if you don't get the intuition, let me run it again. Okay. So it is 450 No, let me take this here. Okay. See, we have this array, right? And this is our prefix sum. 4, 9, 9, 7, 4, 5, like this, right? 0, 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. Now, if I say to you, what is the sum of the elements of this array? 3 and 1. So I go prefix of 3 minus prefix of 0. 1 minus 1, right? Which is 0, which is prefix of 3 is 7 minus 0 is 4 is equal to 3. You see, the sum is also 3 here. Right? So to get any subarray sum in this, what we have to find here is the just prefix sum. Now, how can I find that this prefix sum is valid, right? And this prefix sum is valid, right? So I can find this if I get the sum and I modulo this, I can find it, but I have to run it in order of n, right? So if I say here that prefix of this of minus 0, right, modulo so let me see it. Let me build the condition from here. If prefix of 3 modulo 5 is equal to modulo 5, then what I can say, whatever the module, don't care if it can be 1, 2, 3, 4, and 0 to 5 minus 1, it can be anything, right? Now, if I say, then prefix of 3 minus prefix of 0 modulo 5 will always be 0. Like this, their difference will always be valid. Now, if I encounter something like this here, okay, let me say here, this array, right, and I encounter this. The what is the remainder of 1? Right? What is the remainder of 1? 9. 9 modulo 5 is equal to 4 modulo 5. They both are 4. Right? You see, both remainders are like both are 4. And you see also 4 minus this 4. Well, I have to go here, right? 4 is equal to 0. This is division by 5, right? Now, what I can see, 4 is equal to 4 here, right? So I can see like 9 minus 4 modulo 5 is equal to 0. 9, their difference is divisible by 5, right? Or you can see 9 minus 4 is divisible by 5. So we have found a valid subarray, because you see, whatever we have added between this here, right, from here to here, whatever we have added here from here to here, it makes this it makes the multiple of 5 at the end. And whatever number we have added between index 1 and 2, these numbers must add up to multiple of this their difference, right? Which is 9 minus 4, which is 5, right? So what is that? 5 is this making whatever we made it this index from this to it makes 0, but 0 5 mod 5 0 and 0 mod 5 is also 0. So they are both equivalent, right? In modulo arithmetic. That's why we can find that. And in case of this index here, first index, right? If first index is 5, let's say, right? So we have to count that also. We don't have to the two I and j in this case. So to get this, p1 minus p0. P0 is what? Is 0, always 1. So whatever remainder, let's say this 4 remainder is here, and this 4 remainder is also here, that we are counting on remainders. If this remainder is 4, right? So did we see this 4 remainder like any time before? So if I seen here also, if I seen that here also, right? So this 4 remainder will be this array also, this array is also valid, right? So these both are valid. So these two remainders I already seen, right? So this will make pair with both of them. How many times I've seen this remainder? And that will make the difference in that case, and we will get the answer, right? हेलो, कहाँ है भाई? हैं? कहाँ है? क्या कर रहा है? सो रहा था क्या? सोएगा कि जग गया फिर?
सो रहा था, कुछ काम है तो फिर आते हैं लंच के टाइम में।
काम नहीं, मैंने कहा मिल लेते हैं यार। रूम पे ही आ जाता मैं तेरे पे, सोएगा तो शाम को आ जाऊंगा तो सो लेते हैं।
ठीक।
ठीक है। Okay, one more analogy we can take in this is like, let's say we are running on a track, right? Circular track of k meters, right? So each lap is of k meters. Now let's say you start from here and you stop at 3 meters, right? And you drop a bottle here, right? Now you keep adding in this and keep walking, keep walking, keep walking. You have done any number of like laps in this. Like you go and you again find, oh, here I drop my bottle, right? So if you don't count your how much you have traveled, if you are this point again 3, that means you are at you have completed the k meters of your like walking, right? So these 3 meters, these points are the remainders. You see, if you module 3 by k, it will be 3 because the k is whole thing. K, let's say k is 10. So 3 mod 10 is equal to 3 always, right? And you again found it. So the same remainder we are getting for something, that means we have completed a lap. If we have completed a lap, then by adding all the numbers here, we have found a valid subarray, right? So this subarray is a remainder. So this perfect sum divisible by k, multiple of k, right? So this is how, if we get a same remainder, that means we have added enough number of elements that we landed at the same remainder. So this is why our prefix sum array here gave us some this like something like this. We assign library, but then we add, okay, this 3 we have encountered one time, right? Then we encounter it 2 times, right? So we have two valid salary. If we like found this like many 3 2 times, like if we round up third time, then we add it third time. So we have 3 valid salaries. So that's why we have to keep track how many times we have seen this remainder. Means how much we have added valid salaries we have found, right? For the same remainder. If we are getting same remainder, no matter what the remainder is, right? If it can be 3, it can be 5, it can, that means we have a valid multiple of k subarray. So let's say, let's do one more mathematical proof here. Let's say there is a point, right? Present sum, right? Present sum, present like let's say current sum, right? Current sum or prefix sum we have, let's say it is equal to a times k plus remainder it has r2, right? And some past sum we have found in our prefix sum array. There is some current sum, right? There is some past sum, right? And it was like b into k plus r1, right? Now if I do like a subarray sum with these, right? Like we have to do current sum minus past sum, right? It must be equal to valid k. That's it. Why it should be divisible by this, right? Now if my current sum a into k plus r2 minus b into k plus r1, it must be equal to k. That means uh, equal to k, or like it should be multiple of k, right? Multiple of k. That's how it's divisible by it, right? Multiple of k. This is a more accurate statement. Now, if I say, now, if I rearrange this, that a minus b into k plus this is r1, right? R2 minus r1. So this is already multiple of k is equal to multiple of k, right? And here, this is already multiple of k. So to make this multiple of k, r2 minus r1 should have two multiple of k. Like it is possible that their remainder, must their remainder must be same, right? So R2 modulo k is equal to R1 modulo k. This must be same, right? So that means R1 is equal to R2. That should be there, right? Modulo k, because R1 and R2 are like less than k, right? So R1 must be equal to R2 in that case. So that is the only possibility. If we have like remainder equal remainders, then we can find it, right? And the next question we will do, guys, is this. Next question is like geometric grid, uh, called LeetCode 48. Okay, very similar question uh, here. Question number 48. Rotate image. It's a medium text, right? So the question gives us this question here. We have is you are given an n cross n 2D matrix, right? And representing image, rotate the image by 90 degree clockwise. You have to rotate the image in place, which means you have to modify the input 2D matrix directly. Do not allocate another 2D to the rotation. Okay. So let's take this image and how we can do this. Right. Copy the image and take it here. Let's try to one. So how to rotate 90 degree means we have this cell row I comma ci, right? So this row I comma c column I, we have to make how many? Let's say there are k rows and let's say n rows, n cross n. It is right. So where this cell should be here, right? So this is first column. So column is becoming row, right? Ci, and the row I will become where? So row is third. So third becoming one, right? 3 minus whatever the row is, right? Row one or column, not column, row plus one. So n minus r plus one. Is it same? Let's check for this. This is row third comma third comma column two. It goes to row comma uh, 3 minus row is 3 plus 1. not like this. 90 degree we have to rotate it, so this will become n minus r. No, not like this. 3 minus column 3 minus 2 plus 1. Will it work? How did that work in this then? Otherwise 3 2 minus 3 plus 1. Okay. This was first column minus 3 plus 1, which was minus 1. How do you rotate that? So column is becoming row, that's fine. No, row is becoming column is becoming row, that is fine, but how our row is taking place, right? So first thing what we can do, we can achieve rotation by doing two operations, right, on a grid. Like first, we have to swap rows and columns. Swap rows and columns, and then so if I do this, swap row and column. So this was first this will become 1 2 3. This will become 1 2 3, and 4 5 6 and 7 8 9. Then reverse the rows. 7 here, 4 here, 1 here. So that's a two like very simple this uh, so here what we are doing is r comma c is becoming c comma uh, n minus r minus 1. Okay, 3 minus 1 is 1, like this, right? 3 minus 2 minus 1 is no row, right? 3 minus 3 minus 1. N minus 1 minus r, like same thing, right? So 3 minus 1 minus 3 is minus 1. Minus 1 mod 3 is 2. So we have to like make a model also, right? So this has become 2 here. So first we have to change every row to column, right? So every row to column here. Then we have make the change in the columns. Columns means n minus r minus 1. Rotation here is we can achieve like that. Okay, so let's try to code this, right? We have to make n is equal to matrix dot size, right? Whatever. And first I have to reverse the like row. I have to make the rows to column, column to row, right? So for int I is equal to 0, I is less than n, I plus to less. Right? So 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 first what I will do if I am accessing some elements, right? I am choosing some element here, this row. So in this one, so if I am accessing some element this, so I have to first, this is a row, right? So this is a row, we have to change it to column. If I is equal to j, then that's fine, right? Then if I am here, right, then this 2 will be swapped with this, right, with temporary thing. Then if I am here, this will be swapped by this, right? Then this 2, 3 is here, and this here, if I go here, this will be swapped by this. So I have to move diagonally, right, like this diagonally, and then outer row, then here, like this. I have to move like this, right? Okay. So for int j is equal to 0, j is less than j plus, right? If I is equal to j, then continue in that case. We don't want that, but then uh, what I will do is int temp is equal to matrix of comma j, right? And matrix of I comma j equal to matrix of j comma I, and matrix of j comma I equal to matrix of I comma j. No, not like this. It's temp, right? Like this. Okay. So we have done this for first row. Now on second row, if I am going, right? So I have to start from I is j is equal to I, right? Like this. So that's how, because if I am zeroth row, then zeroth column should be there. If I am first row, then first column must be there. Then we can do this. After this, what I can do, I have to like reverse each row, right? Reverse each row here. So for int I equal to 0, I less than 1, I less, and in this for each row, for int j equal to 0, j is and j plus, and j is less than n by 2, right? And if it is odd or even, we can take care of it like okay, I can take a while loop here, right? I can take a while loop. And I equal not j. J is equal to like left and right. L is equal to 0 and R is equal to n minus 1. While uh, L is less than R, what I will do is int temp is equal to matrix I comma L, right? And matrix of R is equal to I comma R is equal to matrix of and comma L equal to matrix of I comma right? And then matrix of I comma r equal to 10, like this. I can do this, right? All the rows, and after all, I can I have to take care of this, right? Now it's looking fine. What I have to return it? Nothing. Okay. Am I doing this thing right or not? I J J I J. Okay. So temp is I J. I J I have. I can modify I J now. I J J I J I. Then okay. It's right. Okay. Right. So time limit exceeded in this. Why? It's okay. Okay. I didn't do things correctly. L plus plus R minus minus. Okay. It's working here in test cases, guys, and let me see if this rotation is working or not. Okay, we have done it. Uh, Next question we can encounter, guys, is this. Here it is water and jug program 365, right? Here. So we have given two jugs. So in this problem, we have given two jugs with capacity X liters and Y liters here. So you have an infinite water supply. Okay. We have to determine whether the total amount of water in both jugs may reach target using the following operations. Fill either jug completely with water. Okay. Completely empty either jug. Pour water from one jug into another until the receiving jug is full or the transferring jug is empty. Here its capacity is given. Now we have one jug which has capacity 3 and another jug 5. So let's say we filled the 3, right? We pour this in this 5 one, right? So this is 3 and this is again empty. And then again what we will do is we again fill it full. Then we again poured it. So this will become 5. This will become 5 and this is empty. No, this is 1 now, right? This is 1. And then I empty this one. So now this is empty, this has 1, right? Now I just pour this 1 in this. So this has 5 has 1 and 3 is empty. Now I fill it. So 5 is 1 and this is full. 3 and 3, I pour it here. So this will become 4. Target is achieved. Target is achieved, right? This is true. So how did we get here with this reasoning, right? If it is possible or not like this. So when it is possible when if we what is the trick in this, guys? So this is this problem directly translates to a linear problem equation which is called Diophantine Diophantine equation, right? Like we have ax plus by equal to z, and mathematically this is only possible, right? This is only possible if GCD of x comma y is equal to multiple of z. This is only possible. Right. So we have to write a GCD function to instantly evaluate if the target is reachable. Right. So we master this specific math. This will also particularly crucial for cryptographic security. Right. And the exact same extended Euclidean algorithm used to solve the jug puzzle from the mathematical foundation from realizing norms reuse attack, right? Private key extraction and replay vulnerabilities. So this is a very important So as you can see here, we have 3, 5, 4, right? 3, 5, 2 jugs, and 4 is here. What is the GCD of 3 and 5? It is 1. Is this multiple of 4? Or are these just like numbers? 3 comma x plus 5 is equal to 4. Can we get these x comma y? No, the a and y are not this. X and y is this. A3 plus b5 is equal to 4. And 3 comma 5 GCD, greatest common divisor, is 1 in this case. Is this 1 is multiple of 4? And if I take next solution here, example, which is 2 comma 6, target is 5. Okay. If I try to solve this, right? 2 comma 6 and target is 5. What is the GCD of 2 comma 6 is 2. Is 2 multiple of 5? No. Right? It's not possible. So to understand this, let the jug capacity are x and y, right? Because we can only manipulate water in fixed chunks of x and y, right? The total amount of water we can possibly measure at any time is exactly represented by a linear combination of like any capacity of A plus by is equal to z. So where a and b are integers, right, representing how many times we filled and emptied uh, the jug, each jug, and z is our target amount, right? Now, Bijot identity is a theorem from number theory that solves this exact equation. So that states like this equation has two integer solution if z is multiple of greatest common divisor of, if z is a multiple of GCD, right? So okay, Okay, so what I can do, guys, is here. Let me do one thing. Right? If x plus y, right, is less than target, so we have to return false because they can never fill the target, right? Return false. And if x is equal to target or y is equal to target, return true, right? In that case, else what we can do is we have to return the GCD, right? GCD of x comma y if it is modulo target, right? It is multiple of this. Then we can do, but we can write a function of GCD, right? Write it g integer GCD and x comma integer y, right? What I can do is first I can take the remainder, right? If let's say if I want to take the remainder here, right? The GCD of 6 comma 4, this 6 comma 2, right? So what I will do is this is x, this is y, right? So x is greater than y in this case, right? So I will do the quotient is 3 to 6 by 2 is 3, and remainder is 6 modulo 2 is 0, right? 0, so this will become 0, and remainder will become b, and the y, right? Y is equal to remainder, and x is equal to y. Okay, and we then come over again. Okay, so what I can do if y is greater than x, right? Return GCD of y comma x, right? If y is equal to 0, return x, right? And remainder is equal to y mod x. No, x mod y, right? And then return GCD of y comma remainder, right? Is it true? Is it true, guys? If I do wrong answer, why? False, false. No, I think I am doing it right. This should be target modulo this GCD of this must be like this, right? Not the vice versa. I don't write it. Nope, it's working. Let me try this. It's working, guys. Thank you so much for watching, and we will meet you